This lesson is on arithmetic, sequences, and series. And yes, you're probably looking at this word saying, that's arithmetic, and it is spelled exactly the same way, but here I'm using it as an adjective instead of as a noun. So it's arithmetic. So as you'll remember from the last lesson, we talked about sequences being a pattern of numbers that we separate with commas, and a series being a pattern of numbers that we separate with addition or subtraction. Arithmetic sequences are a special version of this, and in arithmetic sequences, you are adding or subtracting to get to the next term. D is going to be that common difference, which is that amount that you're adding or subtracting. So for example, if I said 2, 5, 8, 11, that's an arithmetic sequence because I'm adding 3 to get to the next term. Adding 3 each time. D, my common difference, would be 3 in that case. Now there are two formulas you're going to need to know. A sub n will get us, just like it did before, a specific term. So in this case, we're going to look at the formula which requires us to have a sub 1, which is the first term, and that's not going to change. It's always the first term. And then n minus 1, so our location minus 1, and then we'll multiply that with our difference. And in my example, that was a 3, but it can change depending on each example. And then we also have a formula for the sum of it, and this would be for a finite arithmetic sequence. You would want to know the sum of however many terms, that would be your n, and then that n amount over 2, and then you add your first term and your last term. It's kind of reminiscent of the formula for area of a trapezoid. It reminds me of that, but the way it looks. But anyway, just follow this for when you need to do the sum. Okay, so some examples. For example 1, we want to identify the first term, a sub 1, and the common difference, d. So a sub 1, easy to find. Our first term here is 4. D is our common difference, so what we're going up by each time. And so you'll notice in each case, I'm adding 5 to get to the next term. And so our common difference will be 5. In an arithmetic sequence, it's going to be that same amount each time that you're adding. If you notice that like one time you're adding 5 and the next time you're adding 7 and the next time you're adding something else, then this is not an arithmetic sequence. In an arithmetic sequence, they're all going to be the same amount that you add. And in the second part of this, we have another one. Again, I want to locate the first term, a sub 1, and it'll be, I'm not drawing. It'll be a 34. So our a sub 1 will be 34. And let me see if I can get rid of that. Okay. And following that, we want to find our difference. So if you want to look and see how much you're going up by, I usually just look somewhere in the sequence if I know it's arithmetic and find something that's easy math. So for example, 27 to 20, that's easy math. I'm subtracting 7. So when I'm subtracting, and you'll notice I'm going from high numbers to low numbers, my difference is going to be that negative number. So my difference will be negative 7 in this case. All right, moving on to example 2, we want to find the 14th term of an arithmetic sequence. So if you'll remember, our formula for terms is a sub n equals a sub 1 plus n minus 1 times d. So I need to know several things. I need to know a sub 1, which is 4. I'm going to make us a little list over here. I need to know n. So n would be the location, and they gave that to us in the wording, so our n is 14. And then d is our difference, and in this case you'll notice you're going up by 3 each time, so our difference is 3. So our 14th term, I would write a sub 14 equals a sub 1, so I would replace that with 4, plus n minus 1, so 14 minus 1, times our difference, which is 3. And then I just have to work that out. So this will be 4 plus 13 times 3, which is 43. Okay? You can also use this formula in some different situations. So in this case, they're asking us to find the first term, but they give us the 44th term and the difference. So we have everything we need, we're going to use that same formula and plug it in. So I'll just let us look up here. So instead of saying a sub n, I'm going to say a sub 44 is 229. That's what we're going to set everything equal to. And that will equal a sub 1, which is what I don't know, plus n minus 1. And again, since we're using this 44th term, our n will be 44 minus 1 times our d, which is 8. Now, obviously, 44 minus 1 is 43. If I multiply that with 8, I get 344. So I have 229 is a sub 1 plus 344. And it's just an equation, so I'm going to subtract 344. So 229 minus 344 is negative 115. And so that is the a sub 1 that they're asking for. All right, another situation where you can use that formula, it says in the sequence here, which term is 301? In other words, we're trying to find n. If a sub n is 301. So we know that that ending amount is 301. We also know that that first term is 4. So I have 301 equals 4 plus n, which we don't know, minus 1 times d. Well, again, I want to look. My d is 3. And I think this is kind of the same one from above. My d is 3. So after that, you've plugged everything in. The only thing you should be missing is n, and you have an equation. So 301 will equal 4 plus, I want to distribute my 3 in, so 3n minus 3, and so I have 301 would be 4 minus 3 would be 1 plus 3n. If I subtract, 300 equals 3n, and n, when I divide by 3, will be 100. So a sub 100 is 301. Okay, example 5 is worded differently. It says form an arithmetic sequence that has 6 arithmetic means between negative 12 and 23. What that means is you're going to start with negative 12. You're going to have 6 terms that you don't know, and then a 23. Okay, so 6 missing things between negative 12 and 23. Well, what does that tell us? That tells us that negative 12 is a sub 1. And then if you count your location, 1, 2, 3, 4, 5, 6, 7, 8, I know that 23 is a sub 8. I don't know the difference, but that's kind of what they're asking here. So if I plug in, I know a sub 8 is 23. I can say 23 is equal to a sub 1, negative 12, plus n minus 1, so in this case 8 minus 1, because I had 8 things, times d. Finding that d is going to help us just put the numbers in, because we'll be able to calculate that just by hand. So I have 23 equals negative 12 plus 7d. So I need to add 12 to both sides. So I will get, come up here, 35 equals 7d, and if I divide both sides by 7, d will be 5. That means I'm going to add 5 to get each term. So negative 12 plus 5 is going to be negative 7, and then negative 7 plus 5 is going to be negative 2. Negative 2 plus 5 is going to be 3, and then 3 plus 5 is 8, and 8 plus 5 is 13, and 13 plus 5 is 18, and 18 plus 5 is 23. So here would be our sequence after we found that d. All right, next example. The third term of an arithmetic sequence is 8. So I know a sub 3 is 8. The 16th is 47, so a sub 16 is 47. Find a sub 1 and d, and construct the sequence. Anytime I have 2 variables, I need 2 equations. So these 2 pieces of information are going to be 2 separate equations. The first one, I'm going to be able to say 8 is a sub 1 plus 3 minus 1 d. The second one, I'm going to be able to say 47 is a sub 1 plus 16 minus 1, d. And so if I go ahead and simplify these to 2, and then over here, 16 minus 1 is 15. I have two equations with two variables, and that's a case where we can do substitution or elimination or something like that. And I have found that it's pretty easy to do substitution. I'm going to get the a sub 1 by itself here because it doesn't have anything multiplied by it. So I'm going to subtract 2d and say that a sub 1 is 8 minus 2d. I'm going to plug that in over here. So I'm going to say 47 is, I'm going to take out this a sub 1 and put in 8 minus 2d, so plus 15d. Then I can solve for d, so 47 will be 8 plus 13d. If I subtract 8, I'm going to get 39 equals 13d, and then if I divide by 13, d is going to be 3. So there's my d. All I have to do is plug that in to get my a sub 1. So 8, so I'm going to take that back over here. 8 minus 2 times 3 will be my a sub 1. So 8 minus 6 is 2. My a sub 1 is 2. So construct the sequence. I'm not going to go all the way up to 16, but I'll show you. I know that my difference is 3 and my a sub 1 is 2. So if I add 3 to 2, I'm going to get 5. And add 3 more, I'm going to get 8. And add 3 more, I'm going to get 11. Add 3 more, I'm going to get 14. And I'm just going to put dot, dot, dot. And then our 16th term would be 47. So I'm going to leave it at that. All right, now we're going to get into the sums. So find the sum of the first 32 terms. So that means our n is 32. We also can tell that our a sub 1 is negative 12, and if you're looking, you're adding 6 each time. So our difference is 6. Now, thinking about that formula, sum of n was n over 2 a sub 1 plus a sub n. I have the n, I have the a sub 1, I have a d, but what I don't have is an a sub n. I'm going to have to get that from the a sub n formula. So I'm going to take this information and plug it in. A sub n is a sub 1 plus n minus 1 times d. So I can get that as a number. And in this case, that's 174. Now I have all the parts I need to find the sum. So I'm going to say sum of the first 32 terms would be 32 over 2 times negative 12, which is a sub 1, plus 174, which is a sub n. And then I'm just going to plug that in my calculator, and that gives me a 162. The thing is, yes, I plugged it in the calculator. That's just for speed. This isn't too bad if you have to multiply it out by hand. So you do get 162. Okay. Find the sum of the first 100 natural numbers. So natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So your n here would be 100, and your a sub 1 would be 1. And since we know the natural numbers just go up by 1 each time, we also know a sub 100 is 100. So the sum is not too bad in this case. So the sum of the first 100 terms would be 100 over 2, first term plus last term. So I'm looking at 50 times 101. And again, I'm just going to stick that in my calculator, although it's not crazy to do out by hand. You're going to get 5,050. All right, another example, we want to find the sum of the first 15 terms, so n will be 15 of this sequence. Again, a sub 1 is going to be 4, and then if you look, our difference is 3. I think we've used this one several times. So our difference is 3, and since we're finding the sum, I will need to know what that 15th term is, which means I have to use that a sub n formula. So I'm going to say the first term plus n minus 1 times our difference, which is 3 in this case. So 4 plus 14 times 3 is 46. So a sub 15 is 46. My formula, I would say the sum of 15 terms is 15 over 2. A sub 1 is 4. And a sub 15 is 46. So I'm looking at 15 over 2 times 50, which that will reduce. I'm really looking at 15 times 25, which is 375. Basically, once you have everything you need, you just have to plug it correctly into the formula. Alright, the last one I want to show you how sigma notation can be simplified using this arithmetic sum formula. And you may be thinking that this is not arithmetic looking because you're not just simply adding or subtracting to get to the next term, but if you start plugging things in, you'll realize, for example, 1 times 4 is 4, plus 5 is 9. 2 times 4 is 8, plus 5 is 13. 3 times 4 is 12, plus 5 is 17. And 4 times 4 is 16, plus 5 is 21. And I could keep going. But what you'll notice, once you start making that series, if you wrote it out, or that sequence if you wrote it out, you're actually adding 4 each time. And so it is arithmetic. So I plugged in 1 and I got out 9. That makes a sub 1 be 9. Obviously, I'm adding 4 each time once I look at the numbers that come out of it. So my difference is 4. And then in this case, I don't have to go through the a sub n formula to get the last term. I can just plug in 130 because I know that's the last one. So my a sub 130 would be 4 times 130 plus 5. 4 times 130 plus 5 is 525. Okay, so I can also tell that I'm doing 130 terms. N would be 130. So my sum to 130 would be 130 over 2, a sub 1, which is 9, plus a sub 130, which is 525. So I'm going to again go to my calculator because that's going to save me a little bit of time. And if I let it do the math for me, I've got 34,710. And that is quicker than writing out 130 terms. That's not something that you want to write out 130 terms and add them up like we were doing in the previous lesson, just learning how to read this. So if you plug in, you realize you have arithmetic, then jump to the arithmetic formula because it's going to save you some time. And that concludes this lesson.